Okay, so I wanted to start talking about 4.7, inverse trigonometric functions. Let's first remember how we could tell if a function had an inverse. The square root function didn't have an inverse because it failed the horizontal line test. So to get around that, because we know, did I say square root function? I meant x squared. We know that x squared can have an inverse of the square root of x, but we have to restrict the domain of x squared. So they really quietly said for x greater than or equal to 0. So we can restrict the domain for x squared and just look at this portion of the graph, and then it passes the horizontal line test, and we can find its inverse. Well, the same is true for the sine function. If you look, we were just graphing one period of the sine function, but it continues like this. And it most definitely fails the horizontal line test. You can draw those horizontal lines all kinds of places, and it's crossing that sine curve in multiple points. So what we do is we restrict the domain for sine of x. And we restrict it between negative pi over 2 and positive pi over 2. Negative pi over 2 to positive pi over 2. So if I just back up and I look at negative pi over 2, so it's here, and positive pi over 2 is here. Maybe I'll do a better one in a minute. If we just restrict the domain between here and here, you get every y value. You have all the way from the lowest point, which is negative 1, all the way up to the highest point, which is 1. And it passes the horizontal line test. So we restrict the domain to negative pi over 2 to positive pi over 2, which means on the unit circle, negative pi over 2 to positive pi over 2, we're only looking at these two quadrants for our angles. So we restrict it from negative pi over 2 to 0, and from 0 to positive pi over 2. And let's see. So I've got the inverse sine function is defined by y equals arc sine x if and only if sine of y equals x. This is really super important. So, and also just as a side note, arc sine of x is the same way that we could write y equals sine inverse of x using the negative 1 power. Arc sine just looks a little fancier, just like we could talk about y equals x plus 5, but f of x just looks a little fancier. I mean, it's a different notation, but it means the same thing. If and only if the sine of y equals x, where x is between negative 1 and 1, and y is between negative pi over 2 and positive pi over 2. The domain of y equals the arc sine of x is negative 1 to 1, and the range is negative pi over 2 to positive pi over 2. Well, Miss Stewart, on this other page, you said the domain was negative pi over 2 to pi over 2. And you pointed out right here, the range was between negative 1 and 1. That's right, I did. And you need to remember that the domain of the function is equal to the range of its inverse, and the range of the function is equal to the domain of the inverse. That's why if we want to find the inverse of this function, the very first thing we do is we switch the x and the y. the domain and the range. And in fact, on a test question, I think I said if negative 3, 1 is a point on the function, then what's a point on the inverse? And you told me 1, negative 3. You just switched your x and your y. So that's why over here, when we're talking about the inverse function, the domain is the negative 1, 1. And over here, when we were talking about the normal function, the range was negative 1, 1. So there's that relationship. Okie dokie. Let's see. I like this phrase, the arcsine of x is the angle whose sine is x. I like that saying. So here, going back to the definition, the arcsine of x is the angle whose sine is x. Let's do this. Let's start with the angle whose sine is x. Y is trapped in the sine function, and to free it, we can take the inverse sine or the arcsine of both sides. The inverse sine of the sine, those undo each other and you just get y. And on the right side it is sine inverse of x now. And sine inverse of x is another way to write arcsine of x. So there's the y equals the arcsine of x, and this is what we started with. So we're able to go back and forth between those two things. I can do that again for you in class if you ask me about that. Example 1. Says evaluate the inverse sine function if possible find the exact value. Don't you just cringe when you see the if possible stuff? Okay, so A part is arcsine of negative 1/2. I like to go ahead and say, like we're using that formula, arcsine that we just wrote down on the other page. Arcsine of something is y. So I like to go ahead and put that there. And then I like to say the angle whose, actually, I like to take the sine of both sides. Sine of the arcsine is negative 1/2. So I'm looking for the sine of y. I'm looking for the angle whose sine is negative 1/2. So we're going to the unit circle. We only look these two quadrants between negative pi over 2 and positive pi over 2. And you're looking for the y value, the sine value of negative 1/2. And it happens down here. ACTS. Get my ordered pair right. At 11 pi over 6, but I need it to be the negative part. So I think that's negative pi over 6. So my y is negative pi over 6. It is the angle 11 pi over 6, but that's not in the range of negative pi over 2 to pi over 2, so we have to use the negative value. All right, B part. I want to find the sine inverse of square root of 3 over 2. Well, I always just set that equal to something. So I'm going to find the angle whose sine is square root of 3 over 2. That's what this means. And if it helps, then you can do the sine on both sides. Sine of sine inverse is square root of 3 over 2, and we get the sine of y. So we want the angle whose sine is square root of 3 over 2, and remember we're restricted to these two quadrants. Sine is positive in this quadrant, so we're looking for the y value of square root of 3 over 2. Probably didn't put it in the right spot. Actually, I did not put it in the right spot. It would be more up here. And that is at pi over 3. So pi over 3 is your answer. Last one. So I'm looking for the angle whose sine is 2. When you look on your unit circle, there are no sine values of 2. Sine only goes up to 1 on the unit circle. This is not possible. 2 is not between negative 1 and 1. Okay, we're going to stop here.